All right, here we go. All right, so we are graphing linear equations. I want you guys to remember that the graph of a linear equation is always a straight line. If you don't get a straight line, you didn't graph it right. It is a straight line. That's why they're called linear equations. All right, I want you guys to remember that a straight line can do four things. It can slant to the right if the slope is positive. It will slant to the left if the slope is negative. And then we have two kinds of, I call them our special straight lines. We have our horizontal lines when the slope is 0. And then we have our vertical lines when the slope is undefined. Now we're going to have to graph the horizontal and vertical a little bit differently than we graph the other ones, just because we can't really use the word undefined to graph an equation, all right? So we're kind of going to graph those ones a little bit differently. They're meant to be easier, to tell you the truth. All right, so guys, they're going to give you the equation of a line in two different forms. Either they're going to give it to you in slope-intercept, our favorite, good old y equals mx plus b. So we can pull the slope and the y-intercept right out of the equation and start making the graph. Or they're going to give you that line in standard form, which was ax plus by equals c. The problem with that form was that a, b, and c are not the slope or the y-intercept. So normally the way we train you guys to graph this is you're going to solve it for y to get them back into that form, and then everything will be right in the world. All right, so let's do it. I've given you a list of steps to follow. First, we're going to graph the ones that are already in slope-intercept y equals mx plus b form. So to do that, all you got to do is pick out your slope and your y-intercept right from the equation. You always plot the y-intercept first, right on the y-axis, and then you use your slope to move to the other points. So I always say we begin with the b and we move with the m. All right, let's do it. Again, I hope this feels easy. Normally you guys, like I said, you guys knock this out of the park, but just to make sure we're all straight, let's do it. All right, so guys, look at the first one. They want us to graph the equation y equals 2/3 x minus 4. So I hope we all agree that this is in y equals mx plus b form. So does anybody know who the m is? Who is the slope here? 2/3. And then the y-intercept, the b, is negative 4. Okay? So first, you plot the y-intercept. You put him directly on your y-axis. So guys, the y-axis, you can either go up or down. It's negative. So go down 4 and put a dot. That's where your first point on this line is going to be. Now you use your slope to move to the other points. Remember your slope. It's rise over run. You will rise up if it's a positive number. You will rise down if it's a negative number. You run side to side. You will run to the right if it's positive. You will run to the left if it's negative. So guys, how do I rise 2? You go up 2 spaces. So count up 2 spaces from that dot. And then how do you run 3? You run to the right 3. 1, 2, 3. Put a dot. And that's how we create this line, by using his slope. Now every point is up 2 and right 3. So go up 2 and right 3 again. We got another point. All right, I ran out of graph. So to go the other way, to go the other direction from your y-intercept, I told you guys every slope can technically be written 2 different ways. Maybe somebody didn't get 2/3 if they were calculating it. Maybe they got -2 over -3. Because guys, what's a negative over a negative reduced to? A positive. So to go the other direction, just do the exact opposite of up 2, right 3. Go down 2 and to the left 3 spaces. And you can move in the other direction from your y-intercept. All right, and then just connect your dots. And there's the graph of that line. All right, guys, everybody remember doing this? Like I said, normally it's something you guys remember. Everybody okay at home? All right. So I just want to remind you, the slope was positive, and look how the graph went. It went up to the right. That's what a positive sloping line should do. If yours went left, you know you did something wrong. I also want to point out, I know a lot of students, they hear the word graphing, they're like, oh, I hate graphing. I hope you understand, though, just how important of a tool this is. The graph of an equation is literally a cheat sheet. Every single point, every single x and y value that lives on this line is a solution to that equation. That's what a graph shows you. A graph is showing you all of his answers. Guys, this is the point 0, -4, which means when x is 0, y will be -4. 2/3 times 0 is 0. 0 minus 4 is -4. That's a solution to that equation. That's what a graph is showing you. So a graph is really important. All right, here we go. Let's graph this one. Y equals -3x plus 1, right? Y equals mx plus b. So m is -3. Guys, how do you make it a fraction? Because slope needs a rise and a run number.
Over 1.
Put it over 1. And then b is +1. So we begin with b, we move with m. The y-intercept, the point where it crosses over the y-axis, is at +1. So where is y1? Not 1. It's right on the y-axis. And now we use the slope. Rise -3, which means go down 3. 1, 2, 3. Run +1 is to the right 1. Do it again. Down 3, right 1. I ran out of graph. Now if you want to go the other way, do the exact opposite of down 3, right 1. Go up 3 and left 1. Because remember, somebody could have had this as their slope, and it means the exact same thing. It's still -3. All right? And there we go. And there's your negative sloping line to the left. Guys, thumbs up at home. Are we okay? Yeah? You guys okay here? Everybody's good? All right, so guys, look at this one. Graph y equals -5/2 x. Well, two things. Number one, who is the y-intercept assumed to be when nothing is written out there? 0. So if you want to put +0 to remind you, that's your y-intercept. Another thing with math loves to put the negative to a fraction directly in front. So a lot of students will look at that and like, oh, wait a minute, who's negative, the 5 or the 2? Technically, it's your choice. You can pick either one of them to be negative. You just can't make both of them negative because a negative over a negative isn't negative. So I just get in the habit of always giving it to the top number. So I always think of that as y equals -5 over +2 times x and then +0. I give it to the top. All right, you guys graph this one now and let's see what you get.
You're doing a great job.
Right, the y-intercept was 0, so you start right at the origin. And then your slope is -5 over +2, so rise over run. We rise down 5, 1, 2, 3, 4, 5. We run a +2, so that's to the right 2. I run out of graph, so to go the other way, do the exact opposite of down 5, right 2. Go up 5 and left 2. And then there's your line. Everybody get that? We're okay? Yeah? Everybody at home, you got that? All right, we're going to do the next one. Anybody want to tell me what number is assumed to be in front of this x as my slope?
1.
A -1, right? So now your slope is -1, which we'll put over 1, so we have a rise and a run. And then my b is -2. All right, guys, graph that one, and then we're good with the slope intercept.
You didn't see my phone in here last year, did you?
I did not. I didn't hear it. I didn't see it. Want me to call it?
I know it's not in the room because my watch can't find it.
Oh,
I don't
yeah,
know if
yeah.
I left it in Rory's room or if it's my car. It's one of the two, but.
Yeah. Okay, everybody check your answer. My y-intercept was at -2, so I went down 2 and put a dot because that's where y is -2. And then my slope was -1 over 1, so I go down 1, right 1, down 1, right 1, down 1, right 1, or the exact opposite, up 1, left 1, up 1, left 1, and there is our line. Everybody's good with that?
I don't know why, but I thought x was 0, so I did it straight.
Again, technically if x was 0, there wouldn't even be an x in this equation. So if there's an x with no number in front of it, it's always assumed to be a 1 or a -1 in front, depending on the sign. But you can't assume 0, otherwise there would be 0 x's in the problem. The only time you can assume 0 is out here at the end, when there's nothing to be in front of, technically, okay? All right, so now, if they don't give it to you in slope-intercept form, then they're gonna give it to you guys in standard form. And like I said, it's not that bad. We can change it up. It's just a little bit more work to get started. So if they ask you guys to graph the line when it's in standard form, the first thing you're gonna have to do is solve the equation for y. You wanna get y by itself so that it's back to being in slope-intercept form. You wanna get this in y equals mx plus b form. So you can pick out a slope and you can pick out a y-intercept. And then all the steps are the same as before. I just want to give you guys a heads up. Another way that you can be taught to graph a line when it's in standard form is to find the x and y intercepts. Do the cover and solve, and then you can find the point where it crosses the x-axis. Then you can find the point where it crosses the y-axis, and then just connect those 2 points, and there's your line. My problem with graphing a line that way is the only official points you know on the line are the 2 intercepts. When you get it in slope-intercept form, you can use your slope to create so many official points. So I prefer to graph a line using the slope-intercept method. All right, so here we go. The first thing we have to do is to get y by itself. I know we're in Big Bad Algebra 2, and I probably shouldn't tell you to do this, but I'm going to write the 1 that is assumed to be in front of x, so that when I start solving, I know what number is in front of him. All right, so back in chapter 1, we spent an entire 2 days solving equations for y. So you guys should remember how to do this. So if I want to solve this for y, I got to get 1x and -4 away. We always move the one that's not attached first. So it's minus 1x to the other side. That's going to leave us with -4y's equals. Now remember, I'll never be able to take a -12 and subtract 1x from him. They're not like terms. So I told you guys to get into the habit of putting the x's first and the numbers second so that you'll be in mx plus b form. So I'm going to write the -1x and then the -12. And then the only thing you have left to do to get y by itself is divide everything by -4. So divide this by -4, this by -4, and this by -4. And that leaves you with y equals, a negative over a negative is now positive. 1 does not divide by 4, and it doesn't reduce. So it'll just be positive 1 over 4 times x. And then -12 divided by -4 is positive 3. And now we're back in business, guys. My slope is 1/4. My y-intercept is 3. So you guys graph it and get me that line. The slope is positive, so hopefully your line will slant to the right. All right, double check your answer with mine. I went up 3 where my y-intercept is 3, and then I used my slope of rise 1 and go to the right 4 as my slope, or down 1 and left 4 to go the other direction. Everybody go with that one? All right, I want you guys to do this one. Solve it for y and graph it. I'm going to give you a little bit of a head start, and then I'll start working on it. Got to get y by itself first, and then you can find your slope and y-intercept. We just found out that my cross-country season isn't done. One of our runners got invited to a race up in Homedale. Like, she finished in the top 6 in our section at States. It's great. It's just, I thought we were done. Yeah, I mean, it's going to be great. I'm so happy for her. She's such a good runner. It's going to be very exciting to watch.
So does she then train on her own?
Well,
or with you guys?
Luckily it's next Wednesday, so we usually always have the weekends off, but she's already been training because her dad and her they entered a showcase, so she's had races scheduled all along outside of school, and one of them is this Saturday, so she's already been training for that. I texted her like, hey, if you want to come in, I'll do a distance run with you, but I'm not doing any of your sprint workouts with you. No, thank you. All right, hopefully we all got the equation y equals negative 2/3 x minus 4. And then when we graph it, we're going to go down 4 to where our y-intercept is 4. And we're going to use our slope to move. Negative 2/3, right? So to rise negative 2, we're going to go down 2. And then to run positive 3, we're going to go to the right 3. I ran out of graph already, so now I'm going to go the other way. Instead of down 2, right 3, I'm going to go up 2 and left 3. Up 2 and left 3. And there's your straight line. Oh, I missed the last one. Guys, everybody here okay? Everybody's good? Guys at home, are we good with that? Again, hopefully solving for y is not an issue. All right. Guys, there's a lot of you off camera, and that does not seem good. There's no reason for cameras to be off. Oh, Jalen, welcome. I didn't realize you were there. Jack, Jalen, camera should be on. All right, here we go. Now our horizontal and vertical lines. Guys, you got to be able to recognize right away what's going to make them horizontal or vertical. If you look at their equations, if you are asked to graph y equals negative 5, the first thing your brain should be saying is, where the heck is x? Where's the mx plus b? That's the dead giveaway that this is special. It only has one variable in the equation. Come over here. Graph x equals 4. Where the hell's y? Where's my y equals mx plus b, right? Horizontal and vertical lines should be a dead giveaway as soon as you see their equation, because their equation only has one variable in it.
Can you stop for 1 second?
Yeah.
And just take a look at Jack's background.
Where's Jack? Where's the... How did he do
I
that?
didn't even know you could do that, but I like it.
I like it too. Okay, so to graph a horizontal or vertical line, if you ask me, it should feel easier because all you have to do is exactly what it says. If we're going to graph the line y equals negative 5, then we have to graph a straight line where every single y coordinate is negative 5. So guys, give yourself some tick marks. We have to create a line where every y coordinate is negative 5. So first, figure out where a y coordinate is negative 5. All you can do is go up, down, right, or left. Where is y negative 5? Up 5, down 5, left 5, or right 5? It's down 5. So go down 5, put it up. That is where a y coordinate is negative 5. So now every other dot you're about to make, just make sure it has a y coordinate of negative 5. So guys, if I go up, is y still negative 5? No, now it's negative 4. If I go down, is y still negative 5? No, now it's negative 6. But if I go to the right, is y still negative 5? Yep. Go to the right again, it's still negative 5. Go to the left, it's still negative 5. And it creates a horizontal line where every single y coordinate is negative 5. That's 0, negative 5. That's 1, negative 5. That's 2, negative 5. That's negative 1, negative 5. So just create a line that does exactly what it says. All right, look at this one. Graph the line x equals 4. Again, you should be like, where the heck is y? But that's the sign that this is a special kind of line. Just do what it says. Give yourself some tick marks. Anybody know where an x is for? Up, down, right, left? It's to the right 4. So this is the only kind of line whose first point isn't directly on the y-axis. All right, now I want to make sure that every other dot I draw still has an x-coordinate of 4. So guys, if I go left, now x is 3, so I can't put it there. If I go right, now x is 5, so I can't put it there. But if I go up, is x still 4? Yep. X is still 4. If I go down, is x still 4? Yep. This is the line. It is going to be a vertical, straight up and down line. Right? That's 4, 0, that's 4, 1, that's 4, 2, that's 4, negative 1. Every single point has an x-coordinate of 4. All right, the only way I feel like they could make these more difficult is to make you solve for the variable first. Luckily, if you look at this one, we're used to solving for y. But you guys should notice y is the only variable there. So at the end of the day, the only variable you could solve for is y. So get y by itself, and you end up with y equals 2. So we got to create a line where every single y coordinate is 2. Anybody know where y is 2? Up, down, right, or left? It is, guys? Y is 2?
Oh, wait, no.
Up 2. So you want to create a line where every single y coordinate is 2. So I can't go down and I can't go up because that'll change y. I can go to the right, y is still 2. I can go to the left, y is still 2. So again, it's creating that horizontal line.
So y is always going to be going horizontal.
Y, if it's y equals, what I like to think of it is it goes through the y-axis. And then when it's x, it'll be vertical, it'll go through the x-axis, okay? All right, last one, same thing. When you guys look at this, you should be so trained, y equals mx plus b, y equals mx plus b, that you look at this, you're like, where the hell's y? But it's okay. The minute you know there's only one variable, you're like, oh, okay, it's special, it's horizontal or vertical. The only variable here is x. So just get x by itself because he's the only variable. So add 3. 5x is equal to negative 15. Divide by 5. And x is equal to negative 3. So we have to graph the line where x is always negative 3. So give yourself some tick marks. Anybody know where x is negative 3, up, down, right, or left? X is negative 3 to the left. Thank you. So now you're going to go left, put a dot. You want to make sure that every other dot you draw has an x coordinate of negative 3. So I can't go right and I can't go left because that would change x. But I can go up and x is still negative 3, or I can go down and x is still negative 3. And then you create your nice vertical line. Mine's probably a little crooked, but you get the idea. Okay? Is everybody okay with the horizontal vertical? Because like for some reason, it's meant to be easy, but I'm telling you, I can get a lot of students to get those wrong on a quiz or a test. Is everybody okay at home? Good? All right, well guys, happy birthday, Merry Christmas, Happy Hanukkah. We did not assign any homework today. So you do not have any new homework. You only have the homework from yesterday that is due tonight if you haven't done that yet. What we're gonna do is everybody's on the Google Meet tomorrow. So we're just gonna start your homework with you tomorrow on Delta Math, and then we're gonna let you guys finish it on your own. Whether you choose to stay on the Meet and work on it or leave, it's up to you. But we will start your homework tomorrow with you, and then we'll be good for the weekend. All right? So everybody, we'll see you on the Meet tomorrow. If you have any questions, feel free to hang out. Otherwise, you are good to go. Hey guys, erase yours, okay? Good? Okay.
Miss Hart?
What you got? Is this Jalen?
Yeah.
Good, Jalen, turn that camera. Let me see that face of yours.
Okay, hang on.
Oh, let me start recording. Hold on, don't do it yet. Don't do it yet.